So if we're trying to write word phrases from algebraic expressions, which is what we have on this page, here's your 3 steps that you have to follow. First, start with the variable. This should look kind of familiar. Last time we said start with the variable when we have a word phrase and we're trying to write an algebraic expression. It's the same first step. Start with the variable, then write what's being done to it using keywords. It's pretty much the same idea. We're just kind of going backwards. We start with the variable, we say what's being done to the variable, and then we say what's being done to that, and then we say what's being done to that. And if we have to keep going from there, we will. Finally, check to make sure that it works. Same thing as last time. Go back and look, read it again to make sure that it says exactly what we want it to say. So for example, we have this thing sitting right here. If you just read that, what does it say? 5n, okay? What is the operation going on in between? Multiplication. So we're going to have to come up with a word for multiplication. Now we're going to start with the variable, and the variable is n. So instead of writing n, we're going to write the phrase a number. All right. So I've written down a number. Now I need to write down what's being done to that number. What is being done to that number? It's being multiplied by 5. So if you want to use the word multiplied by, fine. If you want to use some other word that means multiply, like what? Product of, times, then use that. A number times 5. Does that say 5n? Yes. Okay. Or maybe somebody could have written down, I'll just do another one up here, a number. I could have also said over here 5 times a number. Does that say 5n? Yes. Okay. So go back and check to make sure that what you wrote down makes sense for what the original problem was, and you shouldn't have any trouble with doing something like this. All right, so right off the bat, we go from something a little bit more difficult to, or a little bit easier to something a little bit more difficult, but it's not that bad. Let's see if we can piece this thing together. I think that might be the first time I've ever said together correctly in a sentence next to each other. I think that takes skill, doesn't it? Never even knew that was possible. Okay, we have, what does this say? 5z plus 16. All right, we know what it says. Now let's make it say the same thing using keywords. Where do we start? Where? Start with the variable, so I'm going to write down a number. All right, what am I doing to a number first? Multiplying it by 5. So how could I write that? So I could write a number multiplied by 5. Is there another way I could write that? 5 times a number, or 5 multiplied by a number, right? Or the product of 5 and a number. All of those would work. Let's write 5 times a number. Okay, I have 5 times a number now. What happens next? We're going to add 16 to it, okay? So we have that 5 times a number chunk sitting right there. What's happening to 5 times a number? We're going to add 16 to it. So let's use a word that means add plus another word. Increased by the sum of, could go out front over here. 5 times a number and 16, we could do that. 5 times a number and 16 could work. So you have lots of options here. All right, that's the point I'm trying to make. When you're making the word phrase, there's plenty of options. Just pick one. 5 times a number, I think the first thing I heard was plus. So let's write plus. Plus what? Plus 16. Period. Well, actually not a period because it's a phrase, so let me get rid of that period. That's it. 5 times a number plus 16. Start with the variable and work your way out from that. If you do that every time, you should be just fine. Okay? Sometimes you'll have to add something out front. Sometimes you'll have to add something behind. But if you start at that variable, that's your anchor point, and then you build from that thing. Okay? So let's try to talk our way through this one since we haven't seen that sort of thing used before. Where do we begin? Variable will be a number. What are we doing to that number first? Are we multiplying first? What else is being done here? There's an exponent. What happens first? You're going to have to think back a little bit here to like 8th grade probably, when you first learned order of operations. What happens first? Exponents happen first. So we have to take care of the exponent before we can take care of the multiplication. So we're going to have a number, what? Okay, so the verb that we could use there would be, starts with an R. R-A. R-A-I. Raised. A number raised to what? To the 4th what? Power. Okay? So now we have the first thing that's being done to our number. It's being raised to the 4th power. So we have a number raised to the 4th power. Then what's happening to this number? It's being multiplied by 3. So how could I finish this off? You could say multiplied by 3 here. You could say something out front. Since I don't have any room over here, I'm actually going to try to word it so that it goes out front. What can we write there? The product of? Okay, we haven't used that one yet, so let's do that. Let's write the product of. And how do I finish this off? The product of what? 3 and. So now it's very clear. We have 3, and then we have a number raised to the 4th power, and we're multiplying those two things together. I think this is perfect. This is exactly what you should come up with on this one. Any other things that you would write might be confusing. I think this one really says it well. All right, I want to see if you can come up with this one on your own. We'll talk about it here in a couple of seconds. So where should we start on this one? Let me back up. What's the problem with this one compared to the others? There's 2 different variables. The fractions aren't a problem. They just make you uncomfortable. Okay? There are 2 different variables here. That's how this one is different. So, where should we start? Sure, pick one of them and start there. So, how about the first one? That's logical. So, for the first one, we're going to say what? A number. What's happening to that number? Okay, it's being multiplied by 1/2. So how could I say that? Okay, 1/2 times a number times 1/2. Is there another word we could use? Of. We could use of. How would I use of in this case? There it is. Half of a number. Half of a number. Is that not 1/2 times a? Yeah. So half of a number. Okay, what are we doing to half of a number? Okay, so added to some other stuff. So give me a word for added to some other stuff. Plus? Sure. All right, now we're on the second piece. A number. We got a variable again, right? Is it the same variable? And this is where probably some of you made a mistake. If you made it this far and you wrote down a number again, you're implying the same number, okay? Is this the same number? Not necessarily. It's a different variable. It could be anything. It could be the same number, but it might not be. So we have to make that clear, okay? So what'd you say? A different number. Another number, okay? So let's write a different number. I like that. Plus something, a different number. Now all we have to do is put something right here. How could I say that? 6 times a different number? That'd get it done. Are we adding in here? What's going on right here? There's both, actually. There's multiplication happening right here, and there's division happening right here. Which one's happening first? Okay, so let's take care of that first. So we have plus. We have the plus taken care of. I need this. Is this a sum? It's a product. We're multiplying, right? So, plus, how can we say this? 6 times a different number. Does that get it done? Okay. Plus 6 times a different number. Now finish it off. Divided by, sure. So divided by 7. Okay, read it back. Half of a number plus 6 times a different number divided by 7. Does that do it? That does it. So that's the answer. So the key here on this one is we have 2 different numbers. So that means that we have, or 2 different variables, so that means we have to say 2 different numbers. We have a number and then we have a different number or another number, something like that. That distinction. When you have fractions, you can use the word of, indicating multiplication. Or you can separate it out like we did here. Technically, this is 6/7 of C. You could have written that, but we didn't, and that's okay. We took out the multiplication first, and then we handled the division by writing 6 times a different number divided by 7. And that really is the same as 6/7 of C. So now instead of just a phrase, we're going to have an actual sort of story to go along with the phrase. Our task is to sift through the information that they give us that we don't need to find the information that we do need. And really, this is your most basic story problem here. Maybe I should have waited because now there's like gag reflex going on because I just said the dreaded story problem. But that's all this is. We're just picking out information that matters and forgetting about information that doesn't. We're doing exactly what we've been doing so far in this section. And we can all handle that. I know you can. So we have Mr. Martinez orders 250 keychains printed with his logo and 500 pencils with his web address. Write an expression for this situation. And this is all algebra really is. We have some situation, we write down an expression. That's it. All right? So what's the important information here? 250 keychains. Does it matter that it's Mr. Martinez? No. Does it matter that they're printed with his logo? Not really. 500 pencils with his web address. So what's important there? The 500 pencils are important. Does it matter that they have his web address on them to us? Not really in this situation. We're not doing anything with those, so forget about it. How can I write this as an expression? Let's make an algebraic expression for this. Yeah. Yeah, go ahead. So we have 500 of one thing and 250 of another, right? That kind of goes back to that problem where we had 2 different variables and we had to say one thing and some other thing, right? A different number. We have 2 different numbers here. They correspond to 2 different things. So we have to make that distinction when we write down that algebraic expression. So we have 250 keychains, 250 what? What's my number going to be? Like we're going from words to the algebraic expression. So I got to have something. X? How about something different? K? How about something different? Why O? O's a bad one actually. O's a bad variable. Why? Looks like it's 0. Oh, theta? Theta is used, Greek letters are used for angles. We're not there yet. So let's just stick with like our typical Arabic English alphabet. Okay, I want to talk about K. Why did somebody pick K? Because of the fact that it's a keychain. Yeah. How about K? It doesn't always have to be X. So 250K. What else? Okay, why plus? Yeah, how much did he get? We add these 2 things together and now we know. So let's put a plus there, and what am I going to write this time? Sure. As soon as you see that it's 250K, it's logical to say 500P. And then you're done. There's nothing else important in this sentence. Does that make sense? All right, let's see if we can write one for this one. I want you to do it on your own for a second, then we'll talk about it. All right, your cell phone costs $50 and another quarter for each text message you send. Is this a plan that you all would like to have? Probably not, because if it costs a quarter per text message, some of you would be spending hundreds of dollars per month, right? No? I think some of you probably would. This is, believe it or not, when texting first came out, my first cell phone plan, I was allowed to send 4 text messages per month. Per month, 4. That was it. If I did any more than that, it was $1 per message. So imagine that, and think about how many texts you guys sent already during this class probably, right? No, you didn't send any text during this class. But when you go down to the, 4th period, probably you're going to send all kinds of text messages. That'd be a lot of money to be spending just sitting in class. Not good. All right, your cell phone costs $50 plus 25 cents for each text message you send. How could I put this into an algebraic expression? What's the important words here? Okay, we have $50 for sure. Whoa. We have oh, I didn't want to do that either. We have $50 right here. That's important. What else? The plus. That's a key word, okay? So some of you have like this close reading skill. My notation for that might be a little bit different than what you've learned, but that's okay. I'm getting the important information out there. What else is important? Okay, 25 cents, but not just 25 cents. For each text message, okay? And yesterday, if you were listening closely to what I was saying when we were talking about variables, there's that for each gives away the fact that there's a variable there, okay? It's times your number, T, sure, for standing for what? Text, perfect. So what should I write? Okay, $50, thank you, plus, so 0.25, 25 cents, T. And remember to put a little hook on there, or you can use the script T. That's terrible, that looks like an A. That's why I don't use it. Okay, that's also awful. I just stick with the hook on the T and call it good. If you got a nice looking script T, then use that if you prefer. Does this get it done? We're charged with $50 right off the bat, no matter what. And then if we send text messages, we get charged with a quarter each text message we send. What happens if we send 0 text messages? Then we still get charged $50 because that's the monthly fee to have the phone, right? Does that make sense for what we have written here? Yeah. And we're going to be doing this a lot this year. Was this hard? Was it hard? Not really. This is all story problems are. Pull out the important information, write down an equation or expression, and then go from there. That's all it is. So when you get to a story problem, don't freak out. It's just like this. It'll look harder. Maybe it'll be a little harder. But if you practice this all year long, you're going to be just fine by the end of the year. Last thing I want to talk about, writing a rule to describe a pattern. Now, there's a lot going on this page right here. We got this picture with the goofy character guy here, and what's he doing? It's like he's stacking blocks or something, and he's having a good time. So that's what's going on. What else is going on in this picture? What else do we see? We see some measurements. This is probably going down to what? The floor. We're kind of assuming that. And then the other measurement here is telling me what? How high each block is, right? So that means this whole level is probably 3.5 inches tall, which makes this level how tall? And if we then said, how tall is it from the table up to here, how high would that be? Okay, so we kind of understand now the picture, all right? I haven't even looked at what the problem says to tell me to do, but I understand what's going on in this picture. Can you all picture yourselves doing something like this? Yeah, do you want to? Maybe, maybe not, but you can picture it. That's the important thing. So the table below shows how the height above the floor of a house of cards depends on the number of levels. Looks more like blocks to me, but I guess it's cards, and that's fine. What is a rule for the height? Give the rule in words as an algebraic expression. All right, fine. So number of levels, how high is it going to be? Off the ground. We're going to be 24 inches high plus 3.5 plus 3.5 plus 3.5 plus 3.5. In other words, we're going to be multiplying times the number of levels that we have, okay? So that's what's going on in this table. We have 2 levels, so we know that we're going to be 24 inches off the ground, and we're going to have to add to that those 2 levels. Each level is 3.5. So if we're 3 levels up, that 24 is still there, the 3.5 is still there, but now instead of 2 levels, it's 3 levels. Likewise for 4 levels, okay? I want you to think about this for a second. What is that n? What's that?
How many rooms
Yeah, it's a variable. It can be anything. The next one would be 5. Maybe it's 5. Maybe it's 6. Maybe it's 22 levels. Maybe it's Survivor and they have to get up to 8 feet. I don't know, okay? We don't know. That's the point. Once we see the pattern in this table, we can use any number we want and plug it into the pattern, and we will then have our expression. That's what algebra is. So, we have some unknown number of levels. What will I write here for this line? 3.5 times, it's not 5. I don't have 5 there. I have some general number. It's n times n plus 24. Guess what? Give the rule in words and as an algebraic expression. You just did the algebraic expression. It's right there. So the answer would be 3.5n plus 24. That's your algebraic expression. In words, can we do that? So it will be what? I got a number. Then what? Need more than just a number. Times what? 3.5. So times 3.5. And what are we doing to a number times 3.5? Adding. So I don't have any room over here. Give me something that I could write out front to make that make sense. The sum of what? How about 24 and a number times 3.5, okay? So now we are able to come up with an algebraic expression and a word phrase from a picture, basically. These are all good skills to have. This is something that you're going to need to know. Does anybody have any questions on this? All right, well that completes the section then. Go ahead and get going on the homework.